Assalamu alaikum, dear students. We are discussing the concept of derivative, and in previous lecture we discussed the derivatives of trigonometric function. Today we are going to discuss the algebra of derivatives. That is, if we have two functions f and g, x, which are differentiable, then some function and the difference of two functions is defined. That is, fx plus g of x and fx minus g of x is defined. Then the derivative of sum and the difference function, that is d by dx of f of x plus g of x, or d by dx of f of x minus g of x, is actually d by dx of f of x plus d by dx of g of x. That is, sum of derivatives equals to the derivatives of sum. Now the product of two functions is defined fx into g of x, you know it, and the derivative of this fx into g of x is derivative of first function, that is d by dx of f of x into g of x, plus fx, that is first function, into derivative of second function, that is d by dx of g of x. This means that when we have the product of two functions fx and g of x, then the derivative of this product function is first function into derivative of second plus second function into derivative of first. This is called as the product rule of differentiation. Now if g of x is not equals to 0, this means that quotient function is defined, fx upon g of x is defined. Then derivative of this quotient function, that is d by dx of fx upon g of x, is denominator square. In denominator we should write denominator square. In numerator we have denominator into differentiation of numerator, that is d by dx of f of x, minus numerator, that is fx, because fx is here numerator, into differentiation of denominator, that is d by dx of g of x. That is numerator and denominator into differentiation of numerator minus numerator into differentiation of denominator upon denominator square. This is called as the quotient rule of differentiation, because here we know d by dx of f of x and d by dx of g of x. Now the fourth one is, if lambda is constant, then the differentiation of scalar multiplication, that is lambda fx, is actually lambda d by dx of f of x, because lambda is constant, it comes out of this differential operator. Like if we consider x5 plus x square, x raised to power 5 plus x raised to power 2, we have to find d by dx of f of x. Here clearly f of x is sum of two functions, one x square x5 and the second one is x square. This means that differentiation of f of x, that is differentiation of x raised to 5 plus x raised to 2, is differentiation of x5 plus differentiation of x square. Now x5 is of the form of x raised to power n, and we know that differentiation of x raised to power n is nx n minus 1, that is 5x 5 minus 1 plus 2x 2 raised to power 2 minus 1, that is 5x 4 plus 2x. So this means that 5x 4 plus 2x is differentiation of x5 plus x square. Now another one is f of x is x raised to power 4 minus 5. Clearly it is the difference of two functions, one x4 and second one 5. We know that the difference of the derivative of the difference function is derivative of the difference of individual functions, that is d by dx of x raised to power 4 minus d by dx of 5. Now x raised to power 4, its differentiation is 4x 4 minus 1 minus differentiation of constant is 0, that is here 0, it is 4x cube simply. So this means that differentiation of x raised to power 4 minus 5 is 4x cube. Now the other one is f of x is sin x into cos x. Clearly it is the product of two functions, one sin x, second one is cos x. So using product rule of differentiation, and product rule of differentiation states that differentiation of sin x into cos x is first function, that is sin x, into differentiation of second, that is cos, plus cos, that is second, into differentiation of first, that is d by dx of sine x, because sine x is first function and cos x is second function. Now the differentiation of cos is minus sine, that is sine into minus sine x, plus differentiation of cos, sine is cos, that is cos into cos x, that is minus sine square x, plus cos square x, that is cos square x minus sine square x, which is cos 2x. Hence differentiation of sine x cos x is cos 2x. If f of x is tan x, we know that by definition of a derivative, differentiation of tan x is x square x. Also we can write f of x, that is tan x, as sin x upon cos x. So this means that actually tan x is the quotient of two functions, one sine and second one is cos. So using the quotient rule of differentiation, that is d by dx of f of x is denominator, in denominator we have to write denominator square, that is cos square. In numerator it is denominator, that is cos, into differentiation of numerator, that is d by dx of sin x, minus sin x, that is numerator, into differentiation of denominator, that is d by dx of cos. Now differentiation of here sine is cos and differentiation of cos is minus sine. It is simply cos square plus sine square upon cos square. Now cos square plus sine square is 1 upon cos square, that is sec square x. So in this way we also proved that the differentiation by using the quotient rule of differentiation of tan x is sec square x. Similarly you can prove, or you can find the derivatives of sec x, cot x, cosec x, and by using the quotient rule of differentiation. Now the last one is f of x is 5x raised to power 10. Here 5 is constant, so this means that here f is the scalar multiplication of lambda, that is 5, and x raised to power 10. Using this d by dx of f of x is 5 d by dx of x raised to power 10, because lambda is constant, it comes out from this integral, this differential, that is 5. Differentiation of x raised to power 10 is 10x, 10 minus 1, that is 50 into x raised to power 9, because here f x is 5 into x raised to power 10, which is of the form of lambda f of x, and we know that the differentiation of lambda f of x is lambda differentiation of f of x, that is d by dx of lambda f of x is lambda d by dx of f of x. So inshallah in tomorrow's video lecture we will discuss this exercise 13.2, that is exercise related to derivatives. So thank you.